Please welcome Cat Innovation and its co-founders Marcel and Yannick, all the way from Canada.
So, hello everyone. I'm Marcel Nawa, CEO and founder of Cat Innovation, here with Yannick Godbout, my co-founder. Today, I'm very proud to present an innovative solution that empowers women to fight against a bone fracture caused by a critical global health issue I personally faced a few years ago. In fact, my journey started when my 7-year-old mother suffered a hip fracture caused by osteoporosis, an incurable progressive bone disease. I was devastated when doctors said 5 days post-surgery, your mother must get back on her feet soon, otherwise palliative care will be the only option. But thanks, she got okay. So first thing I did was to find out more about the disease. So anyone knows a woman over 45 here in the room? So unfortunately, our project may concern many of you or around you. Osteoporosis impacting hundreds of millions of post-menopause due to estrogen loss leads to 1 in 3 women facing osteoporotic fractures. Shockingly, 1 in 4 will die within a year following a fracture, like Tatiana said earlier. And among survivors, 4 in 5 lose autonomy, while a third are requiring ongoing care. And if you're affected by osteoporosis associated with severe chronic kidney disease, for whom medication is totally contraindicated, these people will experience a really significant unmet medical need. Sorry about that. So the solution, OSTAT, our solution is a non-invasive, non-chemical medical device that uses a patented low electrical current to enhance cell membrane mechanism and facilitate calcium entry, resulting in bone growth. It's free from vibration, muscle contraction, or side effects. People affected by osteoporosis suffer an average bone loss of 3% per year. And during our 10-week clinical trial on 48 women, with only 3 hours of stimulation per week, that resulted in a 2% bone growth only in 10 weeks, compensating maybe the 3% annual bone loss. And our technology, as I said earlier, is free from vibration, muscle contraction, or side effects. So the product that we will be launching are smart clothing, initially designed to target hip and spine, and at some point we'll work on device for arms and legs.
The primary market is addressing the unmet need. So people affected by both osteoporosis and severe chronic kidney disease. That market alone should generate annual revenues of over 500 million euros per year. And we are also addressing other markets, like treatment for diagnosed osteoporosis. And those markets could represent an additional 700 million euros per year. Now, a few words about competition. This slide is very important. Bisphosphonates, pills, and monoclonal antibody injections represent 95% of the osteoporosis market. But those two options are invasive. They pose many side effects. They are not suitable for people affected by severe CKD. And also, they show moderate results of bone growth between 3 to 6% after 3 years of non-stop treatment. And keep in mind that we achieve a 2% increase in bone growth in just 10 weeks. As a result, 25% of patients who receive a prescription to fight osteoporosis refuse the treatment. And among those who start the treatment, well, more than half of them will stop it within the first 2 years. But still, those two medications represent annual sales of $14 billion per year. Now, our go-to-market strategy is B2B2C. We plan to have our product approved by regulators, prescribed by doctors, and reimbursed by public or private plan. Our executive and medical teams are made up of experts from different backgrounds, including many PhDs and 6 physicians from 5 different university hospitals. Finally, our 5-year roadmap includes mainly to launch the R&D of the smart clothing, to conduct the preclinical and the multi-center studies, to start the regulatory process along with experts, and finally to be ready in 4 years to start the launching of our product line. Now, to achieve these milestones, we are opening a seed round. So if you'd like to seize the opportunity to partner with maybe a future unicorn, well, we'd be pleased to discuss with you.
So thank you. If do you have any questions? If not, we can meet at our stand. Any questions? Is there any scientists here? Yeah.
What's your first target market?
People affected by osteoporosis associated with chronic kidney disease. Oh, you know, I mean, first of all, it's going to depend on our regulatory approvals. We're going to file for FDA as well as in Canada and here in the UK and Europe. So we'll see which. I mean, we're going to start commercializing whenever we get. Yeah.
But
I mean, we're focusing obviously on FDA first, and but that might take more time to get the approval than here. You know.
And do you already have some contracts with hospitals to get the clinical research?
We're working right now with hospitals in Canada, in Bordeaux, France, in Malaga, in Canada, in Spain, and as well in Tunisia. Yeah, this is already set up. You know, we just need more money to be able to start.
And the protocol is already ready, so
and we're working with CROs as well.
Just to mention, when you talked about the market size, the number I mentioned is just for those markets, so North America, Europe, Japan, and South Korea. And patents have been filed in those countries in addition to China.
Can you just explain how it works, like how the actual machine?
It's a very low intensity current. That's, obviously it's something that is kind of secret still, but I cannot disclose that much, but there's an effect, a direct, it's mimicking exactly what your body does to enhance or increase your bone density, going through the three phases, which is bone surface area, bone calcium, and then that becomes like increase your bone density. So what we do is we stimulate the cell of the mechanism of the membranes, the cell membranes, and this facilitate the entry of the calcium in your bone cells.
And how long do you have to wear it for a day? What we did in the past was a 10-week study. They were stimulated only 3 times a week for 60 minutes. But what we're going to do during the clinical trial, it's going to be a 20-week trial. They're going to be stimulated 1 hour a day, and this is something you wear, and you can do whatever you want. You can work out, watch TV, or whatever. And but we're going to also follow people. Like the clinical trials will be 20 weeks. One trial on osteopenia, which is the phase before being affected by osteoporosis, which is like the risk of fracture is very high as well. So that means everyone that is close to 40, 45, 50 might be affected by osteopenia. And then we're going to have in parallel another clinical trial on osteoporosis associated with chronic kidney disease, because they cannot take medication for the osteoporosis. And after 20 weeks, we're going to still see these patients 32 weeks later to see if what we did during 20 weeks, if it lasts, if it increases or something. But that's the first clinical trials we're going to conduct. Yes?
I was just curious about the actual fabric and everything. So if in the circumstance that someone has a fracture, how hard is it for them to then put this material on, and what's the...
Yeah, you see, the fracture, based on our KOLs, the physicians working with us, we know that, they know, I'm not the scientist behind the technology, they know that we might have an effect on any osteogenesis bone problems, bone issues, like even fractures, But we're going to find out a way to create the clothing. If it's just for like an arm or a leg, it might be a sleeve. It will be a sleeve, so that would be very easy to get it fixed. And if it's a short or a shirt, we're going to make sure that it's easy to fill up and take off. So that won't be a big problem for sure. Any more questions?
Well, do you have any data on whether the differential density makes a difference because you're targeting locally?
What we know so far, when I mentioned about the 2% increase in 10 weeks, we know the p-values, I don't know if you're familiar with the p-values, it's 0.013. So based on the conventional 0.05.
My question is more about because you're targeting locally.
Yeah, it's locally.
Is that density causing any issues further down the spinal column?
No.
The leg, or because it's differential density from the hip to the leg, for example?
No, I mean, in fact, we're focusing on the hip because of the risk of dying from a hip fracture, that's for sure. You know, the main three fractures on people affected by osteopenia or osteoporosis are, the first one, around the age of 60, it's your wrist. Then around 70 is your spine, and then around 80 is your hip. So we're focusing on hip because, you know, you won't die. You might not die because of a wrist fracture, you know. And we realize that it doesn't matter. I mean, it's not because we are reinforcing the bone or increasing the bone density in this area that we are affecting the rest of the, because the legs, the bone density on legs is higher still than the bone density on your hips.
All right, we do need to move on. But
Thank you so much. Thank you.
Thank you.
See you later, our wisdom.